Hi, I'm Akhilesh Kumar Srivastava from ABES Engineering College, Ghaziabad. In the series of problem solving, I will discuss today with a problem minimum and maximum number. This question has been asked in the Hack with Infy examination, and I hope the solution of this problem will help you in preparing for this examination. Let's look at the problem statement.
So the problem statement says that you are given a number n. You can do the following operation exactly once. Pick two digits d1 and d2, where d1 is greater than or equal to 0 and d2 is less than or equal to n, and replace all the occurrences of d1 in the n with d2. Find the minimum and the maximum number that can be formed by doing this operation exactly once. Here we have to note that the new number that is formed must not contain any leading zeros. The first line contains here the input format is saying that the first line contains an integer n denoting the number, and the number is less than or equal to 10 raised to the power 6. Here is the sample input wherein a number is given as 555, and the maximum number that can be generated from 555 is 999. We can do this by picking a digit 5 and then replacing every 5 with 9. Similarly, we can pick 5, and if I replace this 5 with ones, then the number becomes 111, which is the smallest number. Similarly, when we have a number 9, if I change this number to 1, this is the smallest number, but the largest number, 9 is already the largest number, so there is no change required in this. For the number 98, which is 98, if I pick a number 9 and replace it with 1, it becomes the smallest number. And if I pick 8 and change it to 9, it becomes the largest number, that is 99. So to understand this problem, let's take some more examples and try to understand how can this be solved. So let me take a whiteboard to explain this problem to you. Let's say we have a number 569. So in this number, if I have to form the largest number, so what should I do? I should pick a number from the first digit and replace it with 9. Because of the largest number, the 9 will give us the best result. So I am changing this 5 with 9, and my number becomes 969. If I had a number 565, in that case, I would have selected the first digit and have replaced this with 9. And wherever else 5 is appearing, we would have changed that number also to 9. So my new number becomes 969, which is the largest number that I can form with the given number of the operation. Suppose I have a number 974. For this number, if I pick the first digit, then the largest number is already at the first place. So I cannot change this number. Then I will have to pick the second digit, and in this the second digit is 7. I can replace it with 9. My new number becomes 994. So this is the largest number. Similarly, if I would have 907081, in that case, if I pick the first digit, then the first digit is already the maximum. So I pick the second digit 0 and replace it with the largest number 9. And wherever else 0 is appearing, I will change that number also to 9. So the number becomes 99791, and this is the largest number. So I think the number for the largest number, or the conversion for the largest number, must have been clear to you. So what we are actually applying, actually the greedy approach here. And with the greedy approach, I'm solving this question. So in this question, I am just picking a number, a digit. If that digit can be changed, It's okay because the digit can be changed only if it is less than 9. If it is already 9, then we will have to pick the another digit and we'll have to change that digit. And having changed that number to 9 or that digit with 9, we will have to search the other occurrences of the same digit and we will change that also to 9. So the largest number can be formed like this. Now let's take an example and try to find out how can the smallest number be formed. Let's say we have a number 7617. So here is the number. If I pick the first digit and try to change the first digit with 0, then my number will start with a 0, which is not allowed. So this is not possible. So what we can do, we can pick the 7 and replace it with 1. And wherever else 7 is appearing, I will have to replace that with 1. So my number becomes 1611, which is the smallest number I can form with the given number of the operation or the given operation. Similarly, let's say I have a number 1767. So for this number, 1 is already placed at the first digit. I cannot change it with the other number. If I change it with the other number, that number will not be there. So I pick the second digit, and the second digit is other than 1. So if this number is 7, let's change it to 1. And the number changes to 1161. I am not changing this number 7 to 0 because in the problem, it is said that we cannot have the trailing zeros. So I am not applying this 0 because in the condition it has been given that the number hence formed should not be containing any leading zeros. Fine. So now, having given the same condition, let's take more example. Let's say I have a number 1112. So what we will do, in the greedy approach, we try to find out the first number, and the first number is 1, which is already smallest one because we are not considering 0 here. And then I have a 1 here. Then at the third place also I have the 1. At the fourth place I have the 2. So I will change this number to 1. And if there were number after this, I would have changed that also to 1. If there were 2 after this, but here the 2 is the last digit. Hence, the number which is formed is 1111, and this is the smallest number. So I hope you must have understood that we are applying the greedy approach in which we are trying to find out a digit starting from the most significant digit. If this number or this digit can be changed to the smaller one or it can be changed to 1, we will do that. This is only possible if the first digit is not 1. So if it is greater than 1, then I can change that digit. And after changing this digit to 1, we will have to search for the other digit if any other digit is exactly that one. Let's say I have a number 33073. In this case, I have the first digit, and the first digit can be replaced with 1. And now after this, I will find out where we are finding 3. So wherever we are finding 3, we will have to replace that with 1. So the number hence formed is 11071, which is the smallest number. Now to implement this problem, the implementation of this problem should be very simple. Let's say I am taking this number 33073. So for forming the largest number or the smallest number, I will have to extract the digits of this number. So you must be knowing that the extraction is very simple. I can do the extraction by taking its modulo with 3. Now, there can be many methods which is actually possible. But let's say we are employing a method of storing these digits in the string. So if I store these digits in the string, if I'm extracting from the backside, then the storage of the numbers will be like this, 37033. And after storing this, we will have to reverse this. So first we will have to find out the extraction of the digits, and then these digits will actually be the reverse. It means the last digit will be the first one here, the second last digit will be second here. So we will have to reverse this. So after reversing, I'm finding this. So we have, let's say, this string. In this string, I will have to analyze this, whether my first number or the first character obtained here is 9 or less than 9. So if I have less than 9, then I will replace this with 9 and will search the same character in the entire string. If you're not storing this in the string and you're storing it in the let's say a simple array of integers, let's take it the simple array of integers, then also the solution will be very easy. So let's say you're taking the number, let's say 33073. You have extracted the digit and stored it in some of the vector, let's say, or the array. So 3 will be the first digit that you find, 7 will be the next digit, 0 will be the next digit, 3 will be the next digit, and 3 will be the next digit. So in this is the array of integers or the vector of integers. You will have to reverse this. So reversal is very easy. Extraction of the digit will require order of n time if the length of the number is n. And then the reversal will also require order of n time. You can do it by simply taking a two-pointer approach. I take a I here, I take a j here, and then I will exchange this I and the j numbers. And then I will exchange these two by incrementing I and decrementing j. So I have 3 here and 7 here, and finally I have j here. Wherever the I and the j will coincide, I will stop my operation there. So I have reversed the array that we have found. After reversing it, we will start our processing from the first digit, and we'll see if this first digit is less than 9. If this digit is less than 9, then I will change this number or this digit to 9. So let's do the processing one by one. I have observed that the first digit here is 3, so I'm replacing this with 9. Then I will move, let's say this is the I pointer. I will move to the next step and we'll see that if this is the same number as we have picked. Let's say the first number which is picked is stored in the x variable. So if the second digit is also x, or second number in the array is also x, then I will replace that with 9. I'll move to the next one. So third one is not x, so that remains same. We are not making any change to that. The fourth one also remains the same. There is no change in that. But the fifth digit is actually 3 or x. We can change that to 9. So we have obtained 9, 9, 0, 7, and 9. And having formed this array, or we're having replaced this array, we will have to form a number. And that number will be our answer. So you must be knowing that if you already have a concept of the radixes, so you just make a formula like sum equals to sum multiplied with 10 plus the digit, and then you can find out the answer. So if you pick the 9 first, so this will be 0 multiplied with 10 plus 9. And then if you obtain C here, 7 here, so this will be 9 multiplied with 10 plus 7. Similarly, you can find out this number, and having found this number, you will display this number. Similarly, this is the logic for the largest number. The similar logic can be applied for the smallest number. So where you were searching actually the number less than 9, here you have to search the number greater than 1. So whenever you find a number greater than 1, you replace that number with 1. And wherever you find the occurrence of that number, you will have to replace it with that number. So I think this problem is very easy greedy approach problem, which can be implemented also very easily. Now let's look at the code for the same and see if this code works fine. So here is a simple code for doing the same operation. What we have taken a maximum number as a vector. Then we have taken an input of the number from the user. and then we are extracting the digit of the number and storing it in the max number vector. So each of the digit has been extracted and then have been pushed back to the max number vector. So we are obtaining a vector which is storing the digit of the number, but in the reverse order. So we will have to make it to the forward order. For that, we have reversed this this vector by using a two-pointer approach. We are taking the I at the 0 index and then the j at the last index. If the number has the size 5, then the vector will have the size 5 also. The valid indexes will be from 0 to 4. Hence, we are taking the size of the vector minus 1 as the last index j. So while I is j, I am exchanging the ith and the jth position numbers in the vector. Having done this, we have just displayed this number just to check if my number has been printed correctly. After this, we are actually finding out the digits starting from the first digit or the first position in the vector. So if my number in the vector is 9, then I have to make no changes. But if my number is anything other than this, then I have to change that number to 9, and then we have to search the same digit in the entire vector, and if I find that number at any place in the vector, I will have to replace that with 9. The same thing has been done here. We have first searched that where is the first number which is other than 9 appearing starting from the first number. Again, repeat. We are searching that where my number is appearing in the vector which is not 9. If the first digit is 9, I will move ahead by I++. If my second digit is also 9, then I will again move ahead. So wherever I find that the number is not 9, I stop there and store that number in some X variable. Let's say my number is 99359. My number is, let's say, 99359. So let's write it like this. My number is 99359. So in the vector also, these numbers will be stored like this. So the first number is 9, I move ahead. The second number is also 9, I move ahead. The third number is 3, it means I have to change this number to 9. But before changing it, I am storing this number in some X variable. Let's say the number is not 99359, but it is 993593. So the first time when I have observed that my number is not 9, I have stored that number in some X variable. I have then changed this number to 9, and I'm searching for this X or for this 3 in the entire array after this, entire vector after this. So in this vector, I find that 3 is appearing here. So I will replace this number also with 9. So the new number becomes 99959 and then again 9. So here in this code, in this part of the code, we are doing that. In this part of the code, we are searching for the 9. If there is a 9, I move ahead. If there is again a 9, I move ahead. If again there is a 9, I again do I++. So wherever I find that the number is not 9, I stop there and store that number in some X variable. And then I make the value of that position number with making that position number to 9. After this, I'm searching for the same number in the vector after this position. If this was the ith position, I'm searching for the same number X in the right part of the vector. So wherever I find this X, I replace that with 9. And then I move ahead. So wherever I find this X, I change that number to 9 and move ahead. And finally, I'm printing the number, or finally, I am printing the entire vector. Let's erase these things so that the other things after this appears to you with a greater ease. Okay, so now having done this, I will now search for the minimum number. So we are just printing the maximum number. After printing the maximum number, I will have to print the minimum number. So for printing the minimum number, I need to regain the number. It means I need to regain the digits of the number. So what I've done, when I have already found the vector by extracting the digits, I have stored the same values in some other vector named as min number. So vector integer min number is equals to max number. So whenever first time we have formed this vector and then reversed it, I have stored that in the min vector. So for finding the minimum number, the process is more or less the same. We are searching for a number 1. If there is a number 1 starting from the first digit onwards, I am moving ahead and finding out the next digit. Wherever I find that the digit is not 1, I replace that number with 1 or replace that digit with 1. But before that, I'm saving that digit. Let's say my number is let's say 7 5 2 3 1 7. So in this number, the first digit itself is not 1. So I will replace it with 1 and will search the other digits on the right part if any of the digit is 7. So here the last digit is 7, so that will be changed to 1. Having done this, we have obtained our minimum number as 152317. What if my number was 111767? In that case, the first digit is 1, I will move ahead. The second digit is 1, I will move ahead. The third digit is 1, I will move ahead. The fourth digit is 7, I will replace it with 1. I store this number 7 in some x variable, and I search for this x on the right part. So I find that the last digit is 7, so I will replace that with 1. So the new number which has been obtained here is 161. So this is the minimum. Let's take one more example to understand this. Let's say my number is 106537 or 196537. So for this, the first number is 1. I will move ahead. The second number is 9. It means I will have to change this number to 1. So wherever I find 9, I will change that to 1, but incidentally, I'm not finding it. So if I'm not finding that, it means that we have to move ahead. So we are finding that the number new form, which is the minimum. So taking all these conditions, the program has been written, but this program is a bit wrong. I will test it with some other conditions, but let's see for the conditions discussed till now. Fine. So here what we are saying that the minimum number we are searching for the ones, and wherever I am not finding the 1, I am replacing that number with 1, and then I am storing that number. I'm searching that number in the right part and replacing those numbers also to 1, and then finally displaying that number, which will be minimum 1. So let's see this with the sample test cases, and let's see if my program works fine. So I'm running this program. I now take an input. Let's say my number is 11711. So the first thing that is showing us is the number extracted, and we are storing that in the max number vector. So I'm just displaying that just to test that if my number has been input correctly. So the first digit is 1, which is not 9. So I'm replacing that with 9. And wherever I find the instance of 1, I'm replacing that with 9. So this is the maximum number. Similarly, for finding on the minimum number, the number is 11711. So first number is 1, I move ahead. Second number is 1, I move ahead. Third number is 7, I will replace it with 1. And the next number is 1. Next number is 1. So the minimum number is 11111. Now, let's consider some of the cases for which the answers will be wrong. For example, if I have a number, let's say 7, 0, 5, 3, 1. So here what we have to do, we have a 7. So the first number is 7, which is not 0. So it should be replaced with 1. This is for the first number. Right? This is for the first number. This is replaced by 1. Now I don't find any instance of this number 1 ahead. So all other numbers remain same. If I would have found the 7 anywhere else, I would have replaced that number with 1. Okay, it is fine. What if my number is 1, 0, 0, 3, 3? In this case, the first digit is 3. It's fine. We should not change this number. We should move ahead, and then we have a 0. So my logic says that, or whatever logic I have written, that if it is not 1, then we will have to change this. This is 0. We should not change in this case also. In case I change this number with 1, the number will be larger than the previous number or the whatever number is given. So we should not make this change. So we will have to apply this condition also here, that in case we are obtaining a 0, then also we should move ahead and we should not change it with 1. Fine. I hope you understand this. Let's take one more example. Let's say the number is 10203. So the first number is 1. Let's not change this. The second number is 0. We should not change here also. In case we change this number to 1, our number will become 112. And since 0 is appearing again, this number is larger than the given number. So we should not make any change when the 0 is appearing. So this should be our condition included in the code. I leave this to you for writing. Just remember one thing, that whatever we have done is a very simple greedy approach, wherein I have, just a minute. So we have just written a very simple greedy method approach, wherein I have obtained for a number which is not 9 and replaced it with 9 in case we have to find out the largest number, and we are finding 1 or 0. We are searching for 1 and 0, and whatever number is not 1 and 0, I am replacing that with 1. So this is a very simple program. I hope you can solve this very easily. You should include the condition of 9 in this code. So thank you so much for watching.